Cool. So the agenda for today is we're going to start out with some community kind of intro updates. I'd kind of put out feelers for little lightning talks. They can be a minute, 3 minutes, but rather short, just to introduce either a project or an initiative or just like an update on your project. And then we'll segue from there into our guest speaker today, who's Ryan King from Foamspace. And he'll have the floor for about 20 minutes to tell us about his project and some updates there. And then we like to save a bunch of time for kind of Q&A and open discussion before we'll try and just kind of wrap things up and talk about what we can put on the agenda for a future meeting. So then without delay, we'll jump into our community intros updates. First up was Caitlin Moore with Filecoin Green.
Hi, everyone. I'm excited for this second meeting. I've been looking forward to this all week. Definitely the highlight of my week. My name is Caitlin. I'm with the Filecoin Green team. Filecoin Green is building blockchain infrastructure for projects and companies to make transparent, verifiable, and substantive environmental claims. Our work kind of starts with the Filecoin ecosystem first and foremost. And then our goal is to kind of just make environmental accounting a Web3 superpower kind of generally. So starting with Filecoin and then moving to the broader ecosystem. And like I said, very excited to be here. One of the initiatives or projects rather that we work on is something called CO2.storage. And we created CO2.storage. It's a Web3 storage and compute platform built on top of IPFS and Filecoin. And the reason why we built CO2.storage is because we need better ways to validate, like real world claims, especially when it comes to sustainability, where there's a lack of transparency. And so we really built this with the goal to be able to manage the provenance of data and the validation of data sets on that are stored on Filecoin. And so this is something that we're continuing to work on and build out. Essentially what CO2.storage allows is that provenance tracking, data transformation over any structured data. And one of the biggest use cases that we see and why I'm here is geospatial data. So a lot of our project partners use geospatial data and machine learning, are now using decentralized compute with Bacliao to track deforestation and to make more transparent or have more transparency behind things like carbon offsets and renewable energy certificates. And so, the reason why I'm here today and why I wanted to give a little intro is because as we're continuing to build this out and building out this protocol for tracking data provenance, we're really eager to work with more geospatial data, more people who are experts in geospatial data, to build out new features and, highlight the real use cases of like decentralized tech, especially when it comes to geospatial data. So I'll drop my email in the chat box in case anybody wants to reach out and collaborate. And excited to hear from Ryan and the rest of our community today.
Awesome. Thanks, Caitlin. And you reminded me, we don't have kind of notes going around like last time, but any kind of comments or anything that folks put in the chat will be saved as well. So we can also like circulate like last time, we can do a little bit of summary of any kind of resources and share it that way. Awesome. So next up, we've got Charlie Durand with the Extra Project.
Hi, Tyler. Thank you. Can you let me share my article? I think some pictures will help. Thank you. So, hi everyone. I'm the founder of the project Extra, and we're focusing on 3D our protocol is going to consume a large amount of this data, and it's going to use algorithm to deduce an updated version of the map, a constantly updated version of the map, of a 3D map. It's a use case for digital twin mainly, here you have the end result after 3D surface reconstruction that we are doing with our algorithm, and we actually use blockchain to build the trust and the distribution of value between people who contribute data and people who consume data on the protocol. So I'm going to share an article, this article on the chat, and right now we're working on decentralized computation of this 3D reconstruction process. So we're going to be publishing about that very soon. And yeah, that's pretty much all. Feel free to reach out if you have questions or idea or anything that you'd like to discuss.
Awesome, thank you. Then next up, we had Carson Farmer with Tableland.
Okay, hopefully everybody can see that. I'm going to keep this super brief, but hi everybody, I'm Carson from the Textile and Tableland teams. Happy to be on the second call and excited for some more. So I just wanted to provide a bit of an update on a sort of Tableland status and some of the directions we're exploring, and a few call to actions for folks on the call here that might be interested in helping us learn a little bit more about how people are using geospatial data or data in general in their applications and things. So, but just a quick refresher. So Tableland is a Web3 native relational database. It's built on top of like a rock solid database engine. It's and uses sort of fairly robust database primitives, but built and designed in a Web3 context. So you can build sort of decentralized applications or decentralized workflows to store relational data, and then control access and usage of that data through smart contracts and on-chain events and things like that. So you get this sort of like declarative language of SQL with the sort of imperative language of like Solidity or something like that to control access and usage of that data. A nice feature of this, of course, is that you don't need to make the decision of where you're going to put your static files and things like that. You actually have a full-blown dynamic database that is backed by Web3 primitives. So that's the sort of gist of it. And then I have a bunch of taglines up there if you want to read the like website version of what I just said. And so the quick update, sort of what is new, is for folks on this call, we just added support for the FEVM. So you can actually deploy like contracts to FEVM that interface with Tableland, which is pretty cool. There's still like some features and things that are being smoothed out there, but that workflow already works. So that's pretty exciting. Thanks to the FEVM team for the big launch and getting all that working. We are also currently exploring tighter integration and support with Filecoin storage and Filecoin features in general. And so I'm going to come back to that in a second, because that's where you folks come into the picture. But we also just launched a bunch more robust SQL features and sort of upgraded our SQL specification. One of the really cool things about SQL is how expressive it can be. It's pretty much a Turing complete language to do all sorts of manipulations with data. One of the worst things about SQL is how flexible it can be. Same reason. And so we spend a lot of time sort of making sure that the SQL specification fits in a blockchain world where you have, you need deterministic compute and all that sort of thing. Because at the end of the day, SQL is really just compute over data. We've also added a bunch more chains, or a few more chains. So we're getting pretty close to like any EVM chain that you kind of conceivably would actually have data on is available through Tableland. And then we're also working on a new user-friendly, like emphasis on user-friendly management tool for like deploying, designing, building, and constructing tables over Tableland. And it does a bunch of cool things, or it will do a bunch of cool things like abstract over like gas costs and all the sort of things that make using a protocol difficult, this interface is designed to kind of smooth away that part. So we're quite excited about that. So that brings me to my calls to action. We are looking for user feedback if anyone has any few moments to help us out. So if you currently use, user or database management tools like, pgadmin or like other tools, and have some opinions about what you would like a future version of that to look like, or what you would like a blockchain version of that to look like, we want to hear from you. So get in touch with me, Carson at textile.io. I'll actually just add my email here. Oh my goodness. Hard to type when you're typing quickly. Please do, that would be great. And we'll get you set up with a short survey. The other thing we're looking for, and we're especially excited to talk to existing Filecoin storage clients, the folks exactly like you who have real data that you want to store or are storing on Filecoin. We want to talk to you about how we can make the use and access to that data better and easier and more fun. And so tinyurl.com/AndrewXHill will get you a call free of charge. Very exciting opportunity here with my colleague Andrew, who's on the call right now, I think, Andrew. So hi, Andrew. Hopefully you'll get a bunch of new calls with folks from here. So reach out to me, reach out to Andrew. We want to hear from you, and you can help shape the database of the future.
Awesome. Thanks, Carson. And then last up on the list, we had a couple quick words from John Solly with the Easier Data Initiative.
Hey guys, so I'm the lead developer at the Easier Data Initiative, and our mission is to onboard, retrieve, and analyze large amounts of geospatial data using decentralized storage systems and decentralized technologies. We've just put 300 terabytes of Landsat 9 data onto IPFS and Filecoin. Right now, I'm working on an end-to-end application looking at crop health in Ukraine, given the context of the conflict there. And a call to action, another interesting project we're working on is the idea of a collaborative data stewardship where different universities, different entities could work together to share storage and compute resources. So if anyone is interested in that idea of geospatial data and collaboratively storing or collaboratively sharing compute on that geospatial data, we'd love to hear from you.
Awesome. Thanks, John. So I think we're all set. We'll move on, give the floor to Ryan and let him take it away.
Hey everyone, happy to be here. Let me just get set up 1 second. Okay, so my name's Ryan. I'm here to share kind of what I would see as the past, present, and future of the Foam project. If you're familiar with us, some might be already known to you in the first half of the presentation, but given the audience, wanted to kind of share our background in geospatial work and blockchain, and then get more into what we've been working on currently, which is proof of location. So as a whole, from the Foam project, we kind of have what we 3 main elements. And this is the crypto spatial coordinate. It's kind of an open standard we developed of how you can encode geospatial data into a smart contract. Then a spatial index visualizer. So once you have kind of Web3 on-chain data that is geospatial, like how would you represent that or interact with it visually? And then proof of location. How can you prove that that data is actually from where it's claiming to be? So I'm going to walk through those briefly. And when kind of combining those elements, we kind of see having kind of a cross between a Bloomberg terminal and a Google Maps, where you would be able to see all different kinds of information that is geospatial in one place. It's kind of the vision of interoperability in blockchain. So the first aspect on coordinates, essentially there are no standards that have been agreed on that we've seen in the blockchain space for encoding coordinates. There are many different kind of standards out there. So for example, you can have a street address, latitude, longitude, and proprietary ones like what 3 words you might have heard of. And so one of the problems in at least the EVM is that it's hard to manage float points like latitude and longitude. So we started to look into an open standard that's called a geohash that can kind of encode that information and pair that with a smart contract address. And so the geohash is an open source standard that hasn't really been widely used. So we saw that as a really interesting opportunity to kind of make up a new encoding that builds on top of that. And so the idea is that even if it's at the same exact location, any unique smart contract address can get a unique cryptospatial coordinate, as we called it, out of this kind of mapping. And so this was kind of one of the first things that we worked on many years ago, but was just trying to think of how can you bring a geospatial dimension into smart contracts. And so once you actually have that, there was a question of how do you actually then visualize or interact with that. So what we worked on next was what we call the spatial index visualizer. And so this is basically how do you turn Etherscan into a map with Web3 capabilities. So the interface built on Mapbox and DeckGL from Uber for kind of visualizations, but then being able to actually make Web3 calls, have an API that can index that, and then serve it back to the front end. So this is what we saw as like a next step in being able to bring geospatial and Web3 data together. So kind of the elements of what the spatial index visualizer is, as I said, a front-end visual explorer, and then essentially an interactive map with support for Ethereum logs and indexing. So really the first step of bringing together those elements. And so when you combine kind of like encoding geospatial information into smart contracts and then having a visual explorer, you can build really interesting use cases or interfaces like this for whatever your use case or whatever kind of data you're using with existing kind of Web 2 tooling that's out there. So the next thing that we had worked on after building this coordinate standard and the visualizer was then a points of interest registry. So when you combine those, then you can, one of the use cases we tackled was then bringing points of interest data on chain. So with that, there is a kind of foam map that's still running on Ethereum today with open source contracts and this front end, where you can actually add information onto Ethereum about businesses or points of interest location, and then be able to interact with that with this spatial index visualizer stack that we had developed. So here are some examples of what it would look like, where you would be able to add that information. And there was kind of a challenge game where someone could curate or say that this data is outdated. That was these initial use case around that. So this is what that looks like. And I wanted to share here because while it's extremely expensive due to gas, since this is on the layer 1 of Ethereum, for research purposes, all the contracts are open source and we have testnet versions where everything's sped up and free, so that can be played around with and or built on top of. And I'm going to get into some examples of some things that people built that are also open source and could be continued to be built on. So that information can be found on our developer portal, which is developer.foam.space, where we essentially have examples of how you can use those encoding schemes, as well as use the visualizer stack for your own use case, for whatever you want to build, essentially. Using that existing data, just to give a sense of how we were working with it, that we were encoding things like this geohash I explained, if there were tokens associated with any of this information, the geospatial address, etc. And also developed kind of these API calls so that could be easily built on top of. Relevant to this call, a lot of the metadata for that use case we stored on IPFS. We were running a pinning service and still are. And so that's how you could kind of retrieve some of that information. Don't really need to repeat from the last slide, but just some overview of like how this information was being stored and how it could be retrieved for this geospatial information. So going back to the developer portal, there are kind of examples of how you could represent this kind of data that's on chain in different visual ways. And so anyone can then kind of build on top of that as they see fit or for their own use case. And there were a lot of very exciting ones that have been built out in the past. For example, there was a restaurant review guide with chat and Ethereum IDs, where you could basically start to build a decentralized Yelp on top of that use case. There were different kind of scavenger hunts based on NFTs. And other sorts of things. So in the news most recently has been kind of about Ledger and some controversy about their key recovery. So one of the more interesting use cases that was built on that data set was something called map recovery. And this was a way that you could store your private key with geospatial information as opposed to 12 words. So the way that it worked was with this foam map data, you could pre-commit essentially 12 locations that only you knew about, whether that was like your school, maybe your favorite ice cream store, and maybe a major point of interest like the White House. And then you could actually recover your wallet by submitting those to a smart contract as opposed to 12 words. So this was a really unique use case of geospatial data and wallet security. And you could imagine a future version of this where maybe you have to physically go to those locations to unlock your wallet. So this is just, I think, really scratching the surface of interesting things that can be done with not only storing geospatial data, but then actually integrating that into smart contracts or some sort of automation process. These are some screenshots of how you would use that app to recover your wallet. So you can see here, someone is pre-selecting encoded locations and then being able to recover their wallet by putting this information back into the smart contract that only they knew. So those are kind of the initial elements of Foam on kind of encoding information, visualizing it, and storing it to some extent on IPFS. But what we've been working on more recently is what we call proof of location. And that's essentially bringing things into the real world of how do you verify things in the real world that you want to put on chain. And so today with positioning, primarily we utilize GPS. For your phone to be able to show this blue dot on Google Maps, it needs to be hearing at least 4 satellites from up above. The GPS satellites been operating by the US Air Force and Navy consist of a constellation of 24 satellites. And this has unlocked enormous value for geospatial applications. Think of like Garmin GPS for surveying, all the way to things like Pokemon Go or even Uber. So GPS has been pretty transformational in just the geospatial sector altogether, including other Earth observation tangential satellite networks. But there is essentially a problem that there is no backup or alternative to that system that is widely available. And increasingly, it's becoming clear that this GPS system is not fully secure in the sense that data can't be verified. It's a one-directional system. So you don't actually talk back to these satellites like with your phone. So most use cases in the blockchain space that rely on GPS or location is ultimately like self-reported. So it's hard to verify. And it's quite trivial then to use your phone to basically tell apps that you're in different places. Pokemon Go has one of the largest spoofing communities out there. And projects like StepIn or some other IoT networks in the blockchain space have a very large spoofing problem and have to either maintain blacklists or develop algorithms to try to detect cheaters or spoofing. So in a decentralized, trustless system, if you want to know about things in the physical world, you need kind of a more secure way to verify that data. And so the solution that we have been developing is a crypto-native protocol for terrestrial radios that can provide secure location proofs independent of GPS. The way this works is we utilize time-of-flight algorithms over the air, what you might know as time difference of arrival or triangulation. And the idea is to have incentives for this network to be set up where this service is needed, whether that's a port or a downtown area or somewhere very populated, or for whichever use case may need it. In more detail, the way that it actually works is you need at least 4 radios, we call them zone anchors, to set up a zone of coverage. You can then have more than just those 4, but that's kind of the initial needed. The reason is for X, Y, Z, and then a 4th for time variance. And then the idea is that these zone operators would be essentially entering into a service level agreement to kind of be an authority on time and space in that domain. And then a user, whether that's a person, a vehicle, or what have you, can actually interact over the air with radios with the zone and cryptographically sign a message over a handshake, something you can't do with satellites. And with these kind of signed signatures and handshakes, with this pseudo-ranging kind of distributed radar system we've developed, the zone would be able to localize the user without GPS, but fully based off the system that we've developed, and then issue a proof on chain that then could be used for whichever use case is going on at that moment, sorry. So whether that's unlocking a payment or minting an NFT, or it's being used for just kind of a registry of where something's been over time, that's kind of up to the applications. We see this as kind of a new primitive that then can be built into other applications. So here's an example of just us testing it in the Brooklyn Navy Yard, where we're based here in New York. That's somebody walking around in the zone, and then you can kind of see there, I'll have a next slide, from the interface where we're testing, comparing to GPS and our system. This is a sample of the web app we've developed called Hostel, where you can manage your radios and your zone and see kind of experiment results and localization data. We've developed a custom radio for this. There's a DIY version that's based on a Raspberry Pi and then has a Raspberry Pi hat with an FPGA. The radios use a LoRa, which is a low power IoT radio that is in the license-free spectrum. So you don't need a permission or a license to run these radios. There's a plug and play model, and then we've been there's a DIY model, and we've been developing this plug and play model that is meant to increase performance and fidelity for these radio packets and signals that's required. In addition to hardware, we've developed kind of a software and firmware stack that runs on the radio devices. That's namely called TimeSync, which tags the pseudo-ranging of these radio packets to based on this transmission patterns. And as I mentioned, we have Hostel. More recently, which is the web app. More recently, we've actually integrated IPFS as well, so that that's running on each of the radios. There's a lot of information on this slide, so I'll just speak over it. But essentially that these radios are speaking to each other over radio with a custom transmission pattern, and essentially then generating blobs of like gossip messages and passing that to IPFS with custom IDs that then could be enhancing basically our data flow and making the protocol deterministic for verification. We're also researching for future research into the OP stack, which is optimism, which allows you to launch custom chains with different kinds of precompile research to have smart contracts directly integrate with IPLD in a more seamless way. So I'd be interested to hear if anyone would like to know more about that. But wrapping up in terms of what we've been doing with proof of location and the radios has been testing in a beta program. We have one zone in the Brooklyn Navy Yard where we are based, it's kind of our sandbox environment. And then we have participants across the country and also in Ibiza, Spain, ranging from Texas to San Diego, New Jersey, and Arkansas and other places. For these beta participants, they've been using the DIY version. So there's some photos here of people assembling them with the Raspberry Pis and the hats. And we've had a lot of kind of learnings and takeaways from this beta and are now moving into what we call a MVP of putting all of this information on chain. We've been adding over-the-air signatures between the radios, as I mentioned, the IPFS and IPLD integrations. And then we'll have kind of the proof be on chain soon and bring those to these beta zones. So proof of location we see as kind of a new primitive that could be utilized in all different sorts of use cases, whether that's as a user, your kind of location passport of your own check-ins of where you've been, kind of an addition to a POAP. Can also be used for verification for IoT data collection or different kinds of data marketplaces, kind of enhancing if data has actually been collected at that location. as well as in the supply chain or mobility domains. Definitely in kind of like ports and warehouses, free trade zones, where valuable assets maybe get stolen or moved. This level of verification would be able to bring more security and fraud proofs to their area of domain. So I know that's probably a lot of information, but wanted to overview kind of the elements of Foam, of encoding geospatial information and visualizers that can be used by anyone. I can share links after of where those developer portals are, if anyone wants to look at the past projects made or build off of them. And then on how to bridge that into the real world of how do you actually prove that information in a trustless and fraud-proof manner. So if anyone is interested in also testing the actual radios, our beta is still ongoing. There's different criteria of needing line of sight and power and internet, but otherwise we'd be happy to work with you on testing the radios or looking into some of the past work to build off of it. So thanks everybody for your attention and time.
Awesome. Thank you. That was awesome, Ryan. We've got plenty of time. We've got at least about 20 minutes or so where we can do some Q&A or just kind of open discussion. But following up the talk, I think kind of Q&A is a great place to start. So we're a relatively small group, so I think it's fair if folks want to unmute and ask questions, that's the way to go.
So Ryan, I had a question that I think you already answered. What I was wondering is if your location system works indoors or not, but I saw on that last slide that it said you have to have line of sight to the radios. Is that right?
Yeah, that's correct for the LoRa radio, essentially. In theory, we are like radio agnostic with this because we use a software defined radio pipeline. So we could have a different radio front end. I think like ultra wideband works quite well inside. We're in a warehouse and we've tested it, and just the signal bounces too much. And because we need like nanosecond level precision to get the timing right, it just with this radio front end is really optimized for outdoors. But we could in the future try to port our stack to different radios so that you could have like an indoor version, outdoor version.
Cool. That makes sense. Thanks.
Anybody else? Questions?
I've got a question. Hey Ryan, nice to see you. And so cool to see the journey. And hear about where you are and where you're going. I'm really curious about what kind of adoption or interest you're seeing from the market. There's like clearly so many different use cases for this, but like, yeah, I mean, what have you been finding as far as the first most promising, I guess, industry segments or customer bases to actually work with? And where do you see on your roadmap, I guess, is commercialization even a goal of yours? Or how do you kind of intend to scale this?
Yeah, great question. I think from our beta, we've had like a range of foam enthusiasts to like actual like wireless internet professionals. So one of the takeaways, it's a multi-sided marketplace aspect of the project, in the sense that you need a supply side of hosting, who's actually running the radios, and then that's a prerequisite for having any use cases. So one answer is crypto native use cases, kind of on this enthusiast side, to build mindshare or just show what's possible. It's kind of an initial aspect of like NFT mints or things like that. But also in the refi space, one of our sites is in Amarillo, Texas, with a project called the Gala Life, on kind of regenerating, and has interest in like sensors for natural gas or other kind of like environmental sensors there. But there's definitely a trade-off we've learned of like what the overhead is of needing radios versus like needing the proof. So I think on the refi side, it's kind of more narrowing in on like ag tech, where there's actual like expensive assets or hardware involved. And then, yeah, on the supply side, kind of like wireless internet providers or people who already have locations or poles with PoE, power over Ethernet, and masts already there, and then are kind of enticed by any sort of marginal gains they could get on the what assets they already have. And then, yeah, commercialization, essentially A lot of these systems are based on GPS with really expensive trackers with big batteries and like expensive cloud AWS platforms. So definitely in like high value, like free trade zones, maybe is like or ag tech is like starting points on the commercialization side. But there's also a lot of fun stuff that could happen on the smart contract innovation side, which we're excited to see as well.
Any other questions?
Hey, Ryan, thank you so much for the presentation. I was talking a bit about your project at Consensus 2023 in Austin, Texas. That happened about 2 weeks ago. And one person I was speaking with was talking about how just with GDPR and other other acts that have passed, it's really important for server location to be verified and true. So I was wondering if you've ever thought of your project working with verifying the location of like server racks in a building.
Yeah, I think that's a great use case, especially to this audience about Filecoin or IPFS. Like a lot of the proofs in the actual protocol tell you if your data is on different hardware or hard drives, but they may actually be co-located. So one for those privacy concerns you had, but also if I think there was a server fire in Singapore a few years ago that might have overlapped with some hosts in Filecoin. I'm not sure. I don't have that data, but it's a possibility that like you would want to have node geographic distribution, whether that's for GDPR or if that's for enforcing something with a protocol that you don't want X number of validators in the same country or state. So that would be great if anyone wants to work on a pilot or knows how to get started on a pilot on data server rack location proofs. That'd be great.
I'll add to that topic. Hi, I'm Bill. I work for Storage Labs. So we have 24,000 points of presence around the globe. And we do have people coming to us all the time saying, oh, I'd like to store GDPR data on those. And that is like, Russia has some very interesting laws as well. Like if you store files in Russia, you have to keep a copy in Russia, even though you can keep your copies elsewhere too. So just fascinating laws around the world about where data can be stored. And it's very difficult to, I mean, GDPR doesn't seem to have like exceptions. There's some guidance about how you can store information. But yeah, if there was a solution for that, for the distributed space, it would be extremely interesting. I'd obviously have to be inexpensive because you're doing it thousands of times for all your distributed points, but that's certainly something that we've run up against, which, you know, the overhead of understanding the legal parts of it for all the different countries has been very interesting and difficult. So it's a real interesting problem in the distributed world.
Thanks, Bill. Yeah, I think the actual proving part would not necessarily be expensive. It's just the overhead of getting this zone of coverage. Then yeah, ideally, if you have this zone and someone does the initial overhead, there's multifaceted use cases. So then it kind of makes up for it. So definitely could be low overhead for actually like having this file be proved that it's in this place. It's just like the prerequisite of having the service actually be there.
Yeah, Ryan, I think I remember when I looked at the foam map, you had like an incentive mechanism where it would basically, you could advertise where you want proof of location to be accessible. So I'd love to hear from you on, I know we're in kind of the testing beta stage, but like, are there certain locations around the world that have been flagged as, oh, it would be great if we had a zoning for here, and maybe that list could kind of be populated to figure out where zone acres should go next?
Yeah, thanks for bringing that up. It's called a Signal NFT, where instead of like points of interest, you just stake like in a radius. And that was definitely a idea that was very ahead of its time because it launched before NFT metadata standards were even out. So none of the signals have like unique images. And it's definitely taken much longer to develop out the hardware and deal with supply chain slowdowns through COVID. So there's definitely a gap between the signals that exist already and then like what is now where people might want that coverage, but that's definitely a mechanism we're interested in utilizing still. And that, yeah, to recap, basically, we're not trying to launch and have nationwide coverage of proof of location because we want to make sure there's enough use cases or demand. So let's say you have like 10 zones in different cities working, and someone's like, hey, I want this service in this region. The idea is these signals would essentially give like a bonus multiplier on mining rewards for setting up a zone there. So the idea is to like use kind of capital to drive where physical networks get built so that people are not just like building them in random places and then don't get any use cases.
Carson, did you have your hand up before?
It got answered actually, so.
Oh, cool, perfect.
I've got another question. How do you verify the location of the trust anchors? Because I'm wondering, how would I know we didn't move the trust anchors to exactly the same relative position somewhere else, and then within that little network, things are where they're supposed to be, but in the broader world, it's not actually the same in the right place. Does that make sense?
Yeah, for sure. I guess that's why we called the beta program this trust zone program, because like you're like this trust, like you can trust that it's there by seeing the photos and then physically going to use it. So the idea is like zones like overlapping or near each other could hear each other. So then you could build out from there. If somebody was like physically moving it, they would be offline. So it would be like detected essentially that they're moving it. But then the question we've had for a long time is like a thought experiment is like, well, what if I build a zone in Antarctica, but I'm really not there? And I'll be getting those rewards? And we've actually now seen, if anyone's familiar with the Helium IoT network, they have kind of people doing the same where they like say they're spread out across the city, but they actually put them in their basement and mess with the radio signals to simulate being out there. So our thought was if you just have a zone appear in the middle of nowhere, its rewards are essentially escrowed until somebody who's been in a zone that's already like approved in the system, like physically goes there and interacts with it. And then maybe there's a threshold of like, we actually need 5 people who've been to previously accepted zones to go to this brand new one in the middle of nowhere before it can get it added formally to the system. There's definitely though a period of needing to have like live test nets to play through different gaming scenarios, but that's like the high level thought.
I have a question about the accuracy. You kind of showed the example where you're comparing that 1 point in your setup in Brooklyn, and it was you had like an overlay with a GPS point. So do you find that it's typically as accurate as GPS, more accurate, less accurate, or are there any kind of circumstances where you expect it to work more accurately than others?
Yeah, it's really on the RF environment, which is kind of a black box. I would say our intention is not to, like the accuracy part is not the primary focus, at least currently. It's more on that you couldn't have faked it and the fault tolerant aspect of it. That said, like, for example, in San Diego, where we have a team, they were like consistently getting like 1 meter off location. So that was like quite consistent based on their zone. In the Navy Yard, we've gotten 1 meter. And then in one side of the zone where there's cranes and like other buildings, it starts to just like move to 20 meters. And then the next day with different weather or the crane had moved, it's different in that location. So definitely varies on the RF environment, but it's the primary focus would be on that you actually did this signature handshake over the air so that you at least know that you were in the zone. But the intention is to have it kind of be comparable to GPS. Another thing is people maybe aren't really thinking about this. Your iPhone or Android is doing a tremendous amount of filtering on the GPS signal and combining it with other aspects to make it more accurate. When you actually just get a basic GPS receiver, it's not that great.
Makes sense. Cool. Any other questions? Awesome. Well, if we don't have any more specific questions, we kind of saved some time at the end for just like open discussion. If anybody wants to bring up a kind of any other related topics or items of interest that they want to discuss, we can open it up a little bit, see.
Can start with just one that's not foam related, but just an open question. I know a lot of like talk or attention has been on like how data is being stored and retrieved, geospatial data. I was just curious if anyone's working with how like to retrieve that data and actually like trigger something with a smart contract. Is anyone working on that or seeing good examples of that?
Hey, I lead the data team at Arbol, and we do a lot of work with dClimate. We are releasing a lot of open source tooling. So we've had a couple of years of building up a pretty sophisticated internal system of tools to like retrieve gridded data sets, like large gridded data sets like Era 5 from IPFS in a really optimized way. That would be maybe one component of how to retrieve the data and then serve it into a smart contract. If you're interested, I can set up some time, share the tooling that we have, see if it works for you, or get some input on what you're looking for. Would that be interesting? Also, we're kind of doing the same for station data sets too, like GHCN, those that have like a physical, climate station collecting data. We have some other open source utilities we're releasing for that, which requires kind of different processing than these big gridded. Does any of that sound interesting or kind of what you're looking for?
Yeah, it all sounds interesting. I was just curious in general to know what people are working on specific to like having smart contracts actually be fed or use this kind of data.
It's kind of interesting. Yeah. Anybody else can chime in. I think the one piece that I'm just kind of starting to explore right now is potentially using the graph to index IPFS data. And then from there, potentially could connect to an Oracle for smart contracts. I don't know. These are the things that I'm actually like working on trying to figure out. So I might have some of the tech details wrong, but if anybody has, Carson's saying, or Tableland, maybe if Tableland works, I'm really open to talk to anybody because these are open problems for like practical solutions we really need to solve right now. Ryan, would you mind if I followed up with you after this to get your input on some of the tooling that we have?
If anyone missed it on the slide, I put my email again in the chat.
Cool. I'll send you an email after this. Thank you.
That'd be great.
Yeah, thanks, Ryan, and everyone. I just wanted to say hi and to introduce myself and to say that it's wonderful to be with all of you and to see the different implementations, projects, everything in the ecosystem. And also to introduce and also to kind of follow up on what you asked, Ryan. I'm Ron. Nice to meet you from a small open source project called ZK Maps. And we also met in here and there and there and there. And definitely Foam is the high fidelity kind of solution that we hope for also. But about the implementation of smart contracts and location proving, we're working on kind of a abstraction of proving your location within a region of interest or proving your proximity to another user. So for instance, I could also prove, and the whole effort is for privacy. So we'll have this transparency about the data, but we'll still keep the private element that we want. So for instance, I could prove that I'm within a certain location using ZK proofs, but I could also prove that I'm within a certain radius, and another proof from the other side that they are also within a certain radius, and a verifying contract will check that these proofs intersect. So that's also kind of an interesting utilization, maybe kind of a potential use case also for in between the different nodes and so on. And we're definitely looking for more use cases and more contributors. This is not the call for action, but it will come, definitely. And it's wonderful to be here with you.
Great. It would be great to follow up on that. We're definitely looking now on how our actual proofs will, like what the data structure of the presence claim would be. And if there's any like easy low-hanging fruit encryption to be done there, or then getting to how you actually share it with people. Definitely maybe your existing work can be combined. That would be great.
Wonderful.
Awesome. Any other kind of open discussion topics? If not, I'll just kind of pitch the last kind of wrap up thing would be just thinking about a next meeting. So we've kind of agreed on this bi-monthly cadence. So we're in May. So we were looking at something in July timeframe. And so we're open to ideas for next meetings. If there's any speakers that folks think would be great to invite, you can shoot me an email or we can talk about them for a minute or two. Carson's got his hand up.
Well, I just wanted to see the quick one, which is I have a PhD student who is defending their thesis on Friday, actually. So, you know, everybody cross your fingers for them. But they did some work on basically geospatial data queries across IPFS DHTs, and then they did an additional piece on sort of like degrees of geoprivacy management, so that you can sort of choose to share some level of detail with peers in a decentralized network. So pretty cool stuff. It's obviously very relevant, and it's probably pretty fresh in their minds because they're probably cramming right now to be defending this thing on Friday. So that might be, they might be a great speaker.
Awesome. Thanks for the suggestion. Any others, or it could be speakers, or if folks want to have like a certain deep dive on a topic, we can add that to the list. Of course, we can continue doing those kind of like community updates and intros in the beginning. So if you or anybody else wants to throw your name in there, just shoot me an email and we'll put you on there for the next agenda. But yeah, we've got a few more minutes if anyone's got any suggestions or last things they wanted to chat about. Cool. Well, if not, we can wrap it up. Everyone gets a few minutes back, which is always nice. And we'll try and send out a follow-up email a lot faster than at the previous meeting. So within the next week or two, with just like a link to the video and a short recap, any kind of resources, and also a link to register for the next event. We'll try and pick a date. This way there's a little more lead time. But otherwise, thanks everyone for coming out. Thanks, Ryan, for giving an awesome talk, and everyone else who spoke early on, and hope to see you at the next meeting.
Great to meet you all.
Thank you.
Thank you.
Stay later.
Take care.
Hey, everyone.